Hello students, Miss Swanson here, and today we're going to learn about adding and subtracting in scientific notation. Now you've seen this picture already when we first talked about scientific notation. So we have two learning goals for today: to add and subtract in scientific notation, and to add and subtract in scientific notation when the numbers have different exponents. Now in our examples today, we're always going to use the example when there's different exponents. It's a little bit easier when they have the same exponents, and I'll show you when you should use certain rules based on whether or not they're the same or different exponents. So just a review on scientific notation, it's written as a times 10 to the b, where a is a coefficient anywhere between 1 and 9, and it's often a decimal number. B is an exponent, which is positive for large numbers and negative for small numbers, and the base is always 10. So it's always a times 10 to the power of b. And a reminder about how we use exponents: if we have something like 10 to the power of 3, that means 10 times itself 3 times. It doesn't mean 10 times 3, it means 10 times itself. So 10 times 10 times 10. Similarly, if we have a negative exponent, it's 0.1 times itself, however many times in the exponent. So if it's 10 to the negative 5, it would be 0.1 times itself 5 times. So let's look at how to add in scientific notation, and we'll do this through working through an example. So if you notice in this example, we have 9.84 times 10 to the power of 8 plus 4.64 times 10 to the power of 7. So we have 10 to the power of 8 and 10 to the power of 7. This is an example where the exponents are different, which means we have to do this first step, which you can skip if the exponents are the same. So I put a little star here to indicate that you can skip this step if the exponents are the same. So you're going to rewrite one of the numbers so that both exponents are the same. Now to do that, either you're going to choose the bigger number or the smaller number and move the decimal so that the exponent changes. If you move the decimal towards the left, you increase the exponent, and if you move the decimal towards the right, you decrease the exponent. So those are our rules for making our scientific notation either a larger exponent or a smaller exponent. So I'm going to start off by writing 9.84 times 10 to the 8, and I'm going to leave it as it is. And then I'm going to add that, and I'm going to change this one to 10 to the 8 so that they're both the same. Now in order to do that, I want to increase my exponent from 7 to 8. I'm increasing it by 1, which means I need to move the decimal to the left by 1. So remember, if you look at moving the decimal to the left increases the exponent, I want to increase the exponent by 1, so I move it to the decimal to the left by 1. So I'll end up with 0.464 times 10 to the 8. Our second step is to add the coefficients, and this is the same whether the exponents were initially the same or they were different. So I'm going to end up with 10.304 times 10 to the 8. So our power stays the same. Whoops. And then step number 3, again, is an optional step. That's why there's a star beside it. If you're in a situation where it's not in proper scientific notation, you'll have to move the decimal. To be proper scientific notation, there needs to be one non-zero digit before the decimal. Here it's 10.34. There are 2 digits before the decimal, so we need to move that decimal over. We want to move the decimal to the left. If we move the decimal to the left, that increases the exponent. We're moving the decimal to the left 1 time, so we increase the exponent by 1. So we'll end up with 1.0304 times 10 to the power of 9. Let's look at an example with subtraction this time. So here we have 7.36 times 10 to the 4 minus 2.89 times 10 to the 3. Again, we have different exponents, so we need to do that first sort of bonus step to make the exponents the same. Again, moving the decimal to the left will increase the exponent. Moving the decimal to the right will decrease the exponent. So in this case, I'm going to choose to put both of them with the exponent 10 to the 3. So if I want to decrease the exponent, I move the decimal to the right. So for this one, I'm going to end up with 73.6 times 10 to the 3. And then my other number is 10 to the 3, so I can leave it as is, 2.89 times 10 to the power of 3. Then our second step here is to subtract the coefficients. So if I do the subtraction, I end up with 70.71 times 10 to the 3. So our power stays the same, it's always times 10 to the 3. Our last step, again, is a bonus step. You only need to do this if it's not in proper scientific notation. So one non-zero digit before the decimal. Here we have 70, so there are 2 digits. We want to move the decimal to the left, and when we move the decimal to the left, that increases our exponent by 1. It increases our exponent, and since we move the decimal 1 time, it will increase the exponent by 1. So we end up with 7.071 times 10 to the power of 4. So let's take another look at our learning goals. You should be able to add and subtract in scientific notation, including when the exponents are different. So that's all. If you can do this, fantastic. If not, please rewatch the video. And if you're still having trouble, come ask me in class tomorrow. Alright, that's all for now. Bye-bye.